All right, number theory. So in this video, we're going to look at a place value, uh, greatest common factor, least common multiple, prime factorization. So all those are basically prime factorization, uh, a factoring question, and also consecutive integers. So covers quite a bit. Okay, so as we start off, you always be given a number for place value, 5.4278. Okay, and then the question is always like, what number is in the hundredths place, the thousandths place, the tenths place, things like that. Okay, and so what you want to know is we're going to the right of the decimal, and so the 4, I'm going to run out of room to write here, but is the tenths place, and then just moving to the right, the 2 will be hundredths. Let's say that is hundredths, right? Ending in a THS. The 7 will be thousandths place, and so on. The 8 is 10,000ths, right? And so that's really all they're going to be asking you for, just being able to recognize the place value when using decimals. Okay, so pretty straightforward there. Tenths, hundredths, thousandths, 10,000ths. You won't go any further than, they won't make you go any further than that. Probably not 10,000ths either, really. Okay, so moving on to greatest common factor. So here's one. Right, of we'll say 35 and 210. Okay, so if we're trying to find the greatest common factor of two numbers, we need to list the prime factors of each number and then multiply the factors both of those numbers have in common. Okay, so let's start with 35. So all you really can do is do this and like list out the prime factors, right? So we always start off with 1 and whatever the number is. So 1 times 35 is 35, right? And as you go further, there's only 2 left. 5, 7. 2 10s is going to have a few more, right? Okay, 35 is not prime because 5 times 7 is 35. 1 is never prime, right? So our prime numbers here are 5 and 7, and that's it. Okay, so let's look at 210. Okay, same. Start with 1 and 210. And so trying to remember, it's not actually necessary to go, like 210 has quite a few factors, right? But it's not necessarily necessary to go through all of them. The only questions you have is, are any of the factors either 5 or 7 or both, right? Because those are the only ones that 35 have, and both of them are going to have them to multiply this together. Okay, but as you kind of go through this for 210, all right, so this is how I do it anyway, is 2 and 105. All right, 105 is half 210. 2 times 105 equals 210. Okay, so that didn't really help us, right? And then we could kind of keep going with 210. 3 times 70 is 210. Right, so I just did 3 and then figured out what the other number was, 70. Okay, again, we're just sort of doing this just to make sure we're used to the idea of finding factors and prime factors. Right, but really we just care about 5 and 7. Okay, so 5. Is there 5 times what equals 210? Is that an integer? 5 times what is 210? Well, it ends up that 5 times 42 is 210. Right, so that works. And for 7, so 5 is a good one. Oops. 5 is a good one. And really run out of room here, but 7 and 30 is 210, right? 7 times 3 is 21. Just add a 0. 5 and 7. Okay, so they both have 5 and 7, right? And so all we do now is multiply those together, and we get 35, right? And then that's going to be our answer, is 35 is the greatest common factor of 35 and 210. Perfect. Okay. So that was greatest common factor. Now the other one, similar but different, is least common multiple. Okay, so let me erase this board here, and we'll go over a least common multiple example. So let's say least common multiple 15 and 25. Okay, and really process the same. So we need to find the prime factors of each and then multiply prime factors together. Okay, so for 15, we'll start with that one. 15, we went 1 times 15 is 15, and then 2 doesn't work, 3 and 5 works, and that's it. That's all we got. 25. Okay, so you get 1, doesn't help us. 25, that doesn't help us. Right, and then the only other one we have is 5, right? Okay. So what are the factors that we want? 3, 5, and 5, right? And so then we're left with 3 times 5 from the 15, and then the 5 from 25. And we multiply all those out. 3 times 5 is 15. 15 times 5 is 75. And that's the least common multiple of 15 and 25. Okay, so there goes that. And one more time, we're going to have to mess with these annoying prime factors. As far as sometimes, they just straight up ask you. Okay, back to my pen. So this one says, what are the prime factors of 30, 30, and 42? Okay, so let's look at this. Actually, let's do instead. I like 30. I like 24 better. 24 and 42. Okay, so we'll start with 24, yeah? Right? Pretty similar process, right? So you got 1 and you got 24. You know that, yeah? And you also got 2 and 12, because 2 times 12 is 24. After that, how about a 3 and an 8? 3 times 8 is 24, right? Just going right through the list. And then after that, we will go 4 and 6. Okay, and that's all we need. For 42, and kind of a drawn out process here, but 1, 42, 2, and 21, 3. 3 times 14 is 21. There's 3 and 14. And then finally 6 and 7. Okay. So then we're looking for what are the prime numbers that are shared, right? So I see a 2 and a 2 that are the same. And I see a 3, which is prime. A 3, and remember that 2 is the only even number that's prime. So all the other evens are gone, so all the rest for 24 are gone, which means we got nothing left these guys can share, right? So 42 has a 7 that's prime, but there's no 7 for 24. So our answer is 2 and 3, right? And that's all you got to do. Okay, so let's be done with prime factors for a while here. There's a lot of prime factors, but that's the basic process that you go through. Got to see a few examples. Math-wise, really not that hard, but you got to know how to do it. That's the way a lot of math is. Okay, factoring. So looks like we're just going to go with a pen for this whole video. Hopefully it's not too annoying. It's kind of slow, but sometimes it's a little bit easier for me to do. So 3x minus 6xy plus 21xz. Okay, how do you factor something like this? Okay, so what we're looking for is what can we take out of each of these numbers. All right, so usually we'll start with the actual number before we get to the variable. All right, so the smallest number we have here is a 3. Right, and so the question is 6 divisible by 3? Right, 6 divided by 3 is 2. Great. Is 21 divisible by 3? 21 divided by 3 is 7. Okay, so that means we can take a 3 out of each of these. Yeah. And that's always going to be the case, is that it's all, all the numbers are going to be divisible by one of these. Okay, and then next is, let's look at x, right? Because there's an x here, there's an x here, there's an x there, right? So if it's in all of them, then we can take this out, the 3x out. And then your other questions are, there's a y here, right? We see this y, but there's no y here, no y here. We can't take y out because it doesn't apply to all of it. And same thing for z, right? There's a z right there, but nowhere else. Okay, so now it looks like a complete mess. So now we know we're taking out 3x, and then we're just multiplying it by something, right? So again, so we started with, it was 3x, and so we don't want to multiply it by x because that would give us an x squared, right? But just 3x times 1 keeps it at 3x, so we're good there. Minus, we have 6xy. So remember that 3 times 2 is 6, so we'll put a 2 here first, and then just a y, yeah? Right? Again, if I put 2xy, then I would get 6x squared y. Now I just want 6xy. So that looks good. And then finally, we've got a plus, and that number 21, 3 times 7 is 21. We've already got the x, and we just need a z. Yeah, and we're done. That's our answer, right? And if you wanted to, back check it, make sure we did it right. 3x times 1 is 3x. 3x times negative 2y is negative 6xy. And 3x times 7z, there's a plus. 3 times 7 is 21 x z, right? And that was our original equation. Looks perfect. We've got ourselves a good answer, and that's the process that we go through for factoring. Okay, and then one more. Okay. Consecutive integers. Okay, so you may think, well, I thought we already, consecutive integers has shown up before in a different section and in a different video. That's true, it has. So if something shows up in more than one video or in more than one section in the app, that should just highlight to you, it's probably going to show up on test, right? This isn't the only type of thing that's like that. Okay, so on this one, actually, I like text mode better. Okay, so we'll do this and then do the problem. Okay, so you're setting up consecutive integers. It's always going to say like 3 consecutive integers total, or 2 consecutive, or 4 consecutive integer total some number, and then you're supposed to solve for what they each are. Okay, so the first integer is x. Second integer is x plus 1. The third one is x plus 2, and so on. Okay, so this one says 3, if I could type it would be nice, 3 consecutive integers is 339. Okay, and then he wants to know what each of them are. Okay, so all we do to set this up is x plus 1 plus x plus 2 equals that, 339. Okay, and then from here, pretty simple algebra, right? We have 3 x's plus 3. Well, it always does that. Equals 339. Okay, subtract 3 from each side. 3x is 336. All right, then you just divide each side by 3. And x equals 112. Okay, and then don't forget that there were 3 integers, right? The second one was x plus 1. So we'll go back and just kind of plug this in. X plus 1 is 113. X plus 2 is 114, right? So there are 3 consecutive integers of 112, 113, 114. If you want, you can back check it, add them together, make sure it equals that, 339, which it does, and then we know we got a good answer. The other way, which is certainly acceptable to do, is if you just really don't like doing algebra at all and want to minimize it, is to just do guess and check, right? So it's multiple choice. You'll have 4 answer choices, and if you just want to make sure they actually are consecutive integers, and just add them together and see which one adds up to the answer, right? One of them is going to. And you can go about doing it that way, and you'll still get the right answer. I'm not sure which one will be faster for you. It kind of just depends on your comfort level with this type of algebra, but you'll get the right answer either way. This is the math way to do it. Guess and check, I'm fine with. It probably will work out just as well.